So thank you very much. This is a fantastic venue and it's great to be here, and apologies that you're speaking to the second Irishman now this afternoon and you have to listen in English, but you know, you can always ask questions later if you can't understand me. What I wanted to present on is not any particular individual thing. I just wanted to take a look at the fixed part of the network. We saw a lot about mobile and 5G. We saw a lot about AI. I'll touch on some speeds that may have been covered before, and I'll touch on where AI impacts access networks. But I just wanted to take a look at where Greece is, first of all, and then really work into what's happening elsewhere. There's a lot of markets that are more mature than Greece, and there's perhaps an opportunity to look at what's happening out in other regions, and maybe you can take a few shortcuts if you prepare now and work appropriately. So the first thing I wanted to look at was really the maturity here in Greece. And unfortunately, I think we've seen already great on the mobile network. Unfortunately, when it comes to the fixed network, it's not so great. One of the roles I've played over the last few years, I headed up the Market Intelligence Committee for the Fibre to the Home Council of Europe for about 4 years, collecting data year on year, watching all of Europe progress towards our full fibre future. And unfortunately, down the bottom of that list consistently was Greece. But 39 out of 40, that's the bad news, but we're going to see the good news in just a minute. And then borrowing on from some of the figures you saw from Ookla earlier, when Luke presented his, 37 out of the EU40 for fixed. You can see there on the mobile network performance, it's much closer to 120 megabits per second versus the 70 megabits per second the average fixed user gets in Greece. So much better position right in the mid-teens when it comes to mobile, but very much still down the bottom when it comes to fixed. But when you're starting from that location, it's very easy to top the growth charts. So looking at the last year in particular, Greece was number 2 for homes passed. I took a 5-kilometer run around Athens and got very wet last night. But one thing I noticed on every second street was the roads were being dug up and fibre was being put into the ground. So I can see that growth happening. You know, it's not just in the Excel sheets, it's out there on the streets of Athens as well. And of course, there's demand. So we're seeing number 1 for subscriber growth over the last year as well across the basket of 40 countries that the FTTH Council used to compare against. That means there is pent-up demand for faster services than they're currently getting on the fixed network as it is today. So it's very easy to get very concerned and busy about doing this work because there's a lot of work ahead. There's 4, 5, 6, 7, 8, maybe a decade's worth of fibre deployment ahead. But that doesn't mean you shouldn't look at what's happening elsewhere and keeping an eye out for innovation elsewhere in the market. So innovation, the slide here, it's really about making changes. And to make my same point again, you know, when you're building roads, you're digging up roads, you have set processes in place, pop up, have a look at the other new methods for deployment that are happening elsewhere in Europe. I've kind of used this word cloud here as a way to guide the presentation when I was putting it together. So you'll see a lot of things in there that make sense. And the first thing really is on the left-hand side is ADTRAN. A lot of you probably don't even know who ADTRAN are. ADTRAN have been around for about 40 years, an engineering company, originally, well, still headquartered in the US, but now probably about 55 to 60% of our people are in Europe, and most of our revenue comes from Europe. So we're very much a European hardware software network vendor. Our R&D labs are in Gdynia in Poland, where we have about 650 people at that location. And even if you look, we're very proud of our patent wall, so innovation has always been a part of what we do. And if I look at our current chairman, Tom Stanton, and even our Jay Wilson, our chief revenue officer, they started off as engineers in the companies, and they have their names up on our patent wall. So we've very much been an innovative company over the 40 years of our existence. And if you had heard of ADTRAN, you probably know us from the SDX OLT that we've been deploying really for the last, I would say, 6, 7 years. And that was our opportunity to be innovative. The last time we had to build a new fibre to the home product, we could have just built a bigger chassis with bigger line cards, but we didn't. We tried to go down. We could see what was happening in the data center world. We could see leaf spine Ethernet switches being deployed for huge traffic scaling. And we wanted to do the same for the access network. So that's what we did. We built an entire family of Ethernet switches that happen to have PON ports on the front. So we could run GPON and XGS-PON out of that family. So if you do know who we are, it's probably the SDX OLT that you heard of us from. What about next? What's happening next? I decided to take 3 ideas here. I wanted to go for faster because everybody loves high speeds. Although maybe latency and upload is just as important. I'm going to concentrate on download when I talk about faster here. I'm going to talk about intelligence. You've just heard about AI. I'm going to talk a little bit about how we're using that to build better products that can then enhance our subscriber experience. And that's the last piece where we'll cover off just a little bit about subscriber experience. I'll mention Wi-Fi 7 briefly in there as well. So I wanted to take a look at the UK market. The UK market's a little bit unique in Europe. They started very late, but they started in a very different economic situation than a lot of other countries. Suddenly there was an awful lot of investment money that was going into the market for fiber build-outs. And what happened then is over 100 different network builders took that investment money and built fiber networks in various different regions around the UK. And bar a few, most of them decided XGS-PON was the technology that they were going to deploy. And that changed the market quite a bit. You'll see on the left-hand side there, UK have also had Europe's first 50 gig PON real live customer on their network in the middle of the year. We'll come back to that in a little while. But they're very much, GPON in the UK is really only being deployed by, I think, maybe 2 to 3 operators, and they're already migrating to a combo approach where they're deploying XGS-PON for their higher tier customers, anything from 500 meg or a gigabit up, while they're still deploying GPON CPE on the back of the same OLT hardware that's running the GPON service as well for their lower tier customers. And so GPON is kind of on its way out, certainly on the OLT side. XGS-PON is where the market is at the moment, and now 50 gig PON is entering the introduction phase. Now don't get me wrong, it's still going to be a few years. 50 gig is not the technology of today. However, some of those leaders in the industry, those who like fiber to the press release, those who need kind of a big bang, 50 gig PON is now just about ready to hold those kind of deployments. And so here is an example of the 50 gig PON running in a triple combo scenario, because we know nobody's deploying 50 gig on top of nothing. A vendor that's deploying 50 gig will have already deployed GPON or will have already deployed XGS-PON and may even have deployed both technologies. That's a lot of CPE out in those customer homes or those businesses that nobody wants to replace. And so if you can enable with triple combo all 3 technologies on the same fiber at the same time, then all you need to do is swap that CPE for those customers who are getting the service or the product of a speed that needs the 50 gig PON service. This was an example here of all 3 running together. At the moment, 50 gig is still asymmetric, but that's just an optical industry problem that is being solved. So we'll see 50 gig symmetric in the middle of next year, but you can see the speeds attainable through that. I'm just going back to that point earlier. We did deploy with EMEA in the UK the first 50 gig PON service on top of an existing XGS PON service, and that's the Ookla speed test. Thank you, Luke, for I don't need to mention who Ookla are, but that is a 40 gig down, 18.5 gigabit up in a residential premises in the UK, and that service has been live since May of this year. So this technology is being built. Is there a use case for it yet? Probably not, but will there be? Of course. Things will always change. 50 gig PON is not about 40 gig services, by the way. 50 gig is about lots and lots and lots of 2 gig, 5 gig, and 10 gig services. And the sweet spot is that 10 gig symmetric service, which is what's driving demand for 50 gig at the moment. It's still very cool to see a 40 gig speed test, however. Moving on to another area, intelligence and innovation. There's really kind of 2 areas we're looking at here. One of them is around predictive network maintenance. We have a lot of hardware in the field. That hardware tends to fail, and quite often it doesn't fail like that. It fails over time. And so being able to tell what parts of the network are degenerating or what parts of the network might need action is important. We've got so much data available to us now. Every part of the network, the in-home Wi-Fi, the the NTU inside the customer premises, the OLT, the aggregation platforms, the WDM platforms. We have information from all over the network. If we can bring that together, we can start looking at networks in a more holistic way. So predictive network maintenance is a major target for us. Also then, autonomous network optimization. So there's many problems that you can figure out that are happening. Maybe they don't need a person to get involved. Now, there's a big level of trust involved in those systems to do that. So we'll talk about some of the ways we're trying to build systems that help bring us that trust. So we're not necessarily there yet for a lot of things, but with the proper training of our own systems, you know, the industry will be there soon. So looking at kind of the AI model here, but it doesn't have to be artificial intelligence. It could just be a business process or some kind of scripting tools that your network operations team pulled together. The idea is, I now have so much data, I still want to look at that data like a human being. I want to be able to look at that data, identify issues, perform my root cause analysis, all of those things, and decide what it is that I want to do based on that information. Then I want to act on that information. Today, that's usually involving a human. That could be through an automated ticket or an email, but we want that to become an automated process. But then we need to provide some way of providing feedback into the system. So we need to collect feedback from our customers. Was that the right thing to do? Was that a good experience or a bad experience? And if so, why? And feed that back into that reasoning process so that the next time it's better. And lastly, explaining. There's no point doing all of this in a black box. You've all used ChatGPT or Gemini to do things. What it does is it explains everything it's doing step by step by step by step. And that gives you trust in those platforms in exactly the same way that network vendors like ADTRAN need to give you trust in the management tools that we put in place. If we can't explain it, then we can't stand over the decisions that are made. So some of the areas that we've already done that, we have various tools across our portfolio. One of them is an in-home help tool that we have on our Wi-Fi 7 management platform, and it gives the customer an opportunity to essentially create their own ticket. Really, that's what's happening in the background, but it lets them explain what's going wrong, what devices are affected, what their experience is, and then the system will get together, pull all of the logs from that platform, upload it to the management system so that tech support can look later, but it'll also try then to identify what the problem could be and what the problem definitely isn't. And it will provide that back to the customer to allow them to take a stab at fixing that issue for themselves. On the right-hand side then, we have more of an agentic AI that was also mentioned earlier, and that's a help desk assistance tool. So we have a customer that calls into a help desk. They will get a nice dashboard with all of the different metrics on there. And there might be 4 alarms on this system. That can be quite overwhelming for a customer care person trying to solve a problem. So what we try and do is identify the root cause, which alarm is causing all the others, or at the very least, which one is the most important. And then we give that customer care agent a walkthrough of what the problem is, what the next steps are, and help them get to the outcome of that problem. So we've built an entire training environment, as I'm sure other vendors have as well, where we can essentially create a lot of these problems and teach the algorithm which are the outcomes that we prefer and which ones are hallucinations from the artificial intelligence piece. The last thing I want to cover then really was around subscriber experience. And this touches on Wi-Fi. We saw Wi-Fi 4, 5, and 6 on the graph earlier. We didn't see 7. It is pretty new. However, there are markets, more mature markets, multi-gigabit markets that are driving Wi-Fi 7 adoption. And again, to go back to the UK, as a multi-gigabit XGS-PON-based market, Wi-Fi 7 is required to be able to get that gigabit experience out of the office or the basement or wherever the router has been installed, to the office, to the kitchen, to everywhere else that I need to be experiencing that fast internet speed. And so that adoption then is forcing service providers to not only manage the access network, they also have to manage the in-home environment. So a lot of companies, ADTRAN included, various others, went their own way and built proprietary solutions because at the time there was nothing standards-based that could give us real-time, scalable, and secure communication with the home to be able to visualize the topology, be able to look at devices as they roam from one access point to another, and be able to tell where maybe the problems are inside that network. So interoperability is the key word for the next, I would say, 2 years. As everybody starts deploying TR369, which is a standards-based management tool which allows us all to essentially speak the same language. And so what we're seeing is vendors of gateway hardware all rushing to support TR369. So you should make sure that you're looking at a TR369 based vendor when you're looking at your gateways. But likewise, the management system has to then adopt TR369, and you have to start going through then and making sure that you can add other vendors. You won't really be able to read that on that screen, but that's just an example of several different vendors working under the Mosaic and Telefy, which is the ADTRAN model. We're moving from proprietary to this open TR369 standard, as many others as well. So with that in mind, I'll just say the only constant is change. Everything is changing. You can easily get busy for the next 5 years building fiber, but while you're building the rest of your network and you're making your plans, have a look outside, see what some of the more mature markets are doing, and maybe you can skip a few steps on the way. And in 5 years' time, instead of catching up with the rest of Europe, Greece can be a leader. With that, F. Christo, thank you. Yes.
You said that right. Thanks very much.